All right, everybody, let's take a little look at solving 3 equations for 3 unknowns with elimination. I'm going to do this one by eliminating this variable z. There's lots of different ways you could do it. You could have chosen the x variables or the y, but I'm going to choose z. So a way that I tend to kick this off is I like to number the equations so I could refer to them. So that's number 1, that's number 2, and that's number 3. And what I'm going to do is use pairs of equations to eliminate the variable z. So for instance, the first move I'm going to make is noticing the coefficient here is 3 and it's 1 there. So what I'm going to do first is I'm going to multiply equation 2 by negative 3. I'm going to multiply this whole equation by negative 3, and I'm going to add it to equation 1. And the idea there is that the term with the z's will cancel. So let's see what happens if I do that. I'm going to do negative 3 times this equation, and I'm going to add it to the one right above. Well, so let's do it. Negative 3 times 2 would give you negative 6. And then plus 1 would give you negative 5. So we get a negative 5x. And negative 3 times 1 plus negative 2 would give you a negative 5y. And then if we look at the z here, you would have, well, negative 3 times this equation, well, plus this term, or negative 3 times z plus 3z would give you 0. So there's no term with z. And then finally, we'll get the constants over here on the right. We would have negative 3 times 4, which is negative 12. And then we would add 7 to that, which will just give you a negative 5. So here's just an equations with x's and y's in there. And so what we've successfully done is we've eliminated z. By the way, noticing this factor of 5 that shows up in each of the terms, if I just divide every term by negative 5, one thing I learned here is that, well, x plus y is just going to be equal to 1. That's if I divide every term by negative 5. So we'll save this equation for later. I'm going to use it for the moment. I'm just going to call it the top equation. I got to give it a name, and you'll see why in a minute. Well, so now look, since I've eliminated z using the top 2 equations, I've used information in the top 2, I've not yet used information in the third. So I need to use equation 3 somehow and go about a process of eliminating z. Well, so what I'm going to do to eliminate z using information in the third equation is what I'm going to do is I'm going to multiply equation 2 by 2 and then add it to equation 3. So in other words, I'm going to say 2 times equation 2, and then I'm going to add that to equation 3. And we'll just go term by term like we did just a moment ago. Well, so let's try it. 2 times 2 would make 4. And then 4 minus 3 would give you 1 x. So this is just going to be x. And then we have our y values here. So 2 times this value would give you 2y. And then plus the term that's in this equation, 2y plus 2y would give you 4y, x plus 4y. Now the z's are supposed to go away here from my plan, but we'll double check. 2z plus a negative 2z would go away. So the z has been eliminated. And then finally, we'll do the constants on the other side here. 2 times 4 would be 8. And then 8 minus 10 will get you a negative 2. And so I'm going to call that equation the bottom equation. So you have the top equation and the bottom equation. Well, now we just have 2 equations for 2 unknowns, the top equation and the bottom equation. And so what we're going to do is now we just need to eliminate one of these variables. Well, so notice if I just do, let's say negative 1 times the bottom equation plus the top equation, that's going to help me eliminate x. So what I'm going to do is I'm going to figure out what is negative 1 times the bottom equation plus the top equation. And let's just see what we get if we do that. So again, negative 1 times this bottom equation plus the top equation. Well, so negative x plus x, well, that cancels the x term, so there's no x term. Negative 1 times, well, 4y would be negative 4y. but then we got to add a y. So we get negative 3y. And now we're already over to the constants, equals. So negative 1 times negative 2 will get you positive 2. And then positive 2 plus 1 would get you a positive 3. Well, so it looks like we have just learned, this is the only variable left here is y, and so we've just learned that y equals negative 1. So therefore, y equals negative 1. And so now what we can do is go back and get, we can just plug this back into one of our previous equations, and that will help us unravel what the other variables are. So let's just plug y equals negative 1 back here into our top equation. I picked that one because it's pretty easy. Well, if we plug it back into the top equation there, what we're going to learn then is that x minus 1 equals 1. Well, so therefore, we just learned that x equals 2. So far we have what y equals and what x equals. And then now that we know 2 of the 3 variables, we can just go back to any one of our original equations and learn what the third variable, what the z is. Just hunting around here, I guess this middle one looks pretty simple. So let's just plug into equation 2. So I'm going to write plug into 2. And so let's go for it. So we would say, well, 2x, so that's going to be 2 times 2. That's going to be 4. Plus y, or plus a negative 1. So I'm just going to say minus 1. Plus z, because z is the thing that we don't know yet. That's supposed to be equal to 4. So it looks like we get 3 plus a mystery number equals 4. So apparently then the z here is going to be 1. So that should solve our system. We've learned y is negative 1, x is 2, and z equals 1. So that solves this particular system. I encourage you to try it again, say by choosing to eliminate y. You already know what the answers are. You could try to go through the same process by, say, using this pair of equations to eliminate y, and then maybe this pair of equations to eliminate y, and you should be able to solve the system and get these same answers. And then likewise, you ought to be able to do it with x also.